When news vendor buys newspapers to sell, they do not know in advance how many they will be able to sell by the end of the day. If they buy too many compared to the actual demand, then there will be a lot of unsold newspapers, which will be expensive or it will eat away their profits. On the other hand, if they buy too little, then there will be missed opportunities. So they could have made more profit. They are not able to make because they purchased too little. So, because demand is always uncertain, it's very difficult to match supply with demand in this case. So, let's look at one example. O'Neill Incorporation, which is a sports apparel manufacturer, and they have manufacturing facility in Mexico, and also they have a contract manufacturer TEC in Asia. So, one of their products is Hammer 3 by 2, which is made at TEC, and they have a lead time of 3 months. So, if the order is given at the beginning of January to produce so many Hammer 3 over 2 suits, it will be available only after 3 months. O'Neill's selling price is about $190 per suit, and TEC charge about 110. So there's a difference of about $80. So O'Neill can make a profit of $80 if they can buy at 110 and sell at 190. So because there is a selling season, it's not that the customer buy these kind of suits throughout the year. So the selling season is generally from the beginning of February to about end of July. So it also means that O'Neill must provide a number that they can tell TEC at the beginning of November. If they order a particular quantity at the beginning of November, so they will be able to receive it before the spring selling season. So O'Neill generally comes out with forecast of sales, and their marketing forecast is about 3200 units. This is a typical news vendor problem where decision maker must decide order quantity before demand is known. If they order too high, if the order quantity is too high, then there will be a lot of unsold suits, or they may have to sell those suits at a heavy discount, and that will incur loss for the company. But if their order quantity is too low, then that's opportunity loss. So they could have made more profit, but because the quantity ordered was too low, they are not able to benefit from that. So news vendor model implementation steps involve generating a demand model, which includes determination of a distribution function that accurately reflects the possible demand outcomes. One statistical distribution that is useful is normal distributions. So we are going to look at some examples involving normal distribution. And then gather economic inputs like what is the selling price, what will be production or procurement cost, what will be salvage value of inventory. And then we choose an objective function where we may want to maximize the expected profit or satisfy an in stock probability. Like we may say that we want to have probability of in stock as high as 90%. So we are able to satisfy customer demand 90% of the time, and the chance of stock out will be only 10%. So depending on what the objective is, one can come out with the quantity that can be ordered. So the first step is to develop a demand model. If the demand forecast is 3200, that's just a number. We need a model that helps to answer many more questions. So this is the historical forecast performance at O'Neill. In the past, they have made similar forecast using the process they have, and this is how that forecast has performed. The forecasted values are on the x-axis and the actual demand is on the y-axis. So there are some cases, for example, this one, where the forecast was slightly over 3,000, but the actual demand was less than even 2,000. So it was somewhere between 1,000 and 2,000. So in this case, their forecast was actually an underestimate of the actual demand. But there was one situation where forecast is close to 2,000, actual demand turned out to be close to 4,000. So it's difficult for a forecast to be accurate all the time. And the further a point is from the line, that's an indication of error between forecasting and actual demand. So closer a point to this line, that means more accurate the forecast is. This historical performance can be used to come out with the demand model. So what we do is we look at each product for which forecast was done in the past, and this column indicates the forecasted value and the actual demand, and forecasted value minus actual demand gives you the error. So for example, for the first product, forecast was 90, whereas the actual demand was 140. So that's a difference of 50 units. So minus 50 is the error in forecast. Last column is A over F, actual demand over forecasted value. So that's the ratio. So in this case, it is 140 divided by 90. So this is 1.56. So after we calculate AF ratio, so what we do is we use the historical AF ratios for developing the demand model. So we start with initial forecast generated from hunches, guesses, or whatever process O'Neill has been using in the past. And using that process, they have an initial forecast of 3,200 units for this item. We then evaluate the AF ratios of the historical data, which is actual demand by forecast, and then we set the mean of the normal distribution to expected AF ratio times the forecast. So that gives us the expected value, and expected value of the demand is also the average or the mean. So expected value is another name for average or the mean. And then we set the standard deviation of the normal distribution to standard deviation of AF ratios times forecast. So based on the last column that we have seen earlier, average came out to be 0.9975 and the standard deviation was 0.3690. So using that, we calculate the expected actual demand as 0.9975 times 3,200, which is the initial estimate for forecast. So that gives us 3,192, and this becomes the mean or the average for the normal distribution. So if you imagine normal distribution to be something like this for demand, then the mean for this is 3,192, and the standard deviation turns out to be 1,181. So the variability which is captured by sigma is 1,181. So now we can use this normal distribution to model demand. So what is a demand model? A demand model specifies what demand outcomes are possible and the probability of these outcomes. Some of the commonly used statistical distributions that are used are normal, gamma, or Poisson distributions. So some examples of their shape are given below. So this red one reflects gamma distribution, which is slightly shifted to the left compared to normal distribution. And Poisson distribution is mostly used for discrete data. So normal distribution is a very popular distribution in statistics, and it has a lot of applications. And it is basically characterized by two parameters. One is mean. So, for example, this picture here, the value against the peak is the mean. So, maybe for some example, the demand or the average demand could be 100. So, that's the mean. And standard deviation is something that captures the variability. For example, if you look at this picture, you can see that there is some variation in the demand. The chances are very high around the mean, but it keeps on reducing on the left side and towards the right side. So that is captured by standard deviation. So instead of probability on the y-axis, if we plot what is called cumulative probability, if we plot cumulative probability on the y-axis, the same picture which we see on the left will change to this type of curve. And instead of a density function, we call this as distribution function for the normal distribution. And the idea is you can choose some probability, let's say 80%, and then against that you can see what is going to be the demand. So if you put your quantity somewhere here, that will mean that you are able to satisfy 80% of the demand. But still there is a chance of 20% not satisfying the demand. So density function tells you the probability of a particular outcome. So one example is, so P stands for probability that demand equals exactly 5. Whereas distribution function tells you probability of a demand which is less than equal to something. In this case, it is 5. So mostly for this type of analysis, we work with distribution functions. So we'll see some examples very soon. These density functions, for normal distribution, it looks like this bell-shaped curve. For exponential distribution, you may see this type of curve. Or if it is a chi-square distribution, for example, so that may be like this, so skewed. So depending on the type of distribution, we may see different curves. But for normal distribution, we see this pattern which is symmetric. Distribution functions always start low and increase towards 1. So if you look at this picture again, so it starts at 0 and then it reaches 1. And the reason is, if you consider a normal distribution like this total area under the curve is considered as 1. So total area or total probability equals 1. Now within the Newsvendor model, let's see how to find the order quantity that will maximize expected profit. So O'Neill sells each suit at $190 and they purchase it from their supplier TEC at 110. But if the demand turns out to be less than expected, then they may have to sell suits at a discount and they may be able to get $90 per suit. So this is also called as salvage value. As we have seen earlier, O'Neill has a problem, something like this. If they buy too much and if they are not able to sell, then they may have to sell at $90, which is at a loss. And if they order too little, then there is an opportunity loss. So they could have made $80 per suit for every extra demand, but they are going to lose. So our demand model is a normal distribution. X-axis is demand which has an average of 3192 and standard deviation or sigma of 1181. So let's look at what are the costs involved with the too much or too little problem. So we denote overage cost as CO, where O stands for overage. The consequence of ordering one more unit than what you would have ordered had you known the demand. So let's say we overordered, we ordered too many. So what will happen? CO is the increase in profit you would have enjoyed had you ordered one fewer unit. So you know that the cost is 110, and then because we have ordered too many, so we may have to sell them at $90. This is going to cost us $20. So that's CO. CU is the underage cost. So suppose we underordered, so demand was more, but the supply was less. So what will happen is CU is the increase in profit you would have enjoyed had you ordered one more unit. So we know that the selling price is 190 and O'Neill has to pay TEC about $110. So difference is $80. So every extra suit would have brought $80 to O'Neill. Now to find the right quantity which maximizes the expected profit, so we have to balance these two risks. So we have to balance the risk and benefit of ordering a unit. So if you look at this curve here for expected gain, in the beginning, when the quantity is smaller and the chances are that you'll be able to sell all the suits, the expected gain is close to 80, but it keeps on coming down because the chance of not selling them also keeps on increasing as the quantity ordered increases. But if you look at expected loss, so on the right hand side, if you order too many, then the expected loss is about $20 that we have seen, because we have to pay TEC 110 and we have to discount suit by selling it at $90. So that's a $20 difference. When the order is too high, the chances are very high that we will not be able to sell many suits. So that will create a loss of about 20. But when the order quantity is less on the left side, that risk is low. So that's why the cost is about zero. As more units are ordered, the expected benefit from ordering one unit decreases while the expected loss of ordering one more unit increases. So that's what you see in this picture. Now to find the right quantity, what we do is we equate expected gain and expected loss and then try to come out with the optimal quantity. So that's what is done here. To maximize expected profit, order Q units so that the expected loss on Q unit equals the expected gain. So basically, once we equate them, what we get in terms of Cu and Co is this equation. So this is also called critical ratio. This ratio that helps in optimizing the quantity level that we can order is also called critical ratio. Hence, to maximize profit, choose Q such that the probability we satisfy all demand equals the critical ratio. So this will help in balancing the two extremes of too much or too little costs. So in case of hammer 3 over 2, the critical ratio comes out to be 0.80. Now, how do we use this to come out with quantity Q that we can use for ordering? Now for that we'll have to make use of normal distribution. So before we try to find this value for Q, let's look at how to do few calculations using normal distribution. When you are solving problems using normal distribution, there are two situations that we generally work with. Let's assume that this is our normal distribution for the demand where average or mean is 3192 and standard deviation is 1181. So I will make up a few situations to highlight the two type of problems that we work with in normal distribution. Let's say we want to find out what is the probability that this demand D is less than 4000. So I can represent this pictorially like this. So this is the normal distribution with the mean 3192 and 4000 is somewhere here. So basically what we want is this area. And you know that the total area under the curve is 1. So this area looks like it will be more than 50%. So finding this area is very straightforward. We'll make use of Excel function. Whenever we use a function in Excel, we start with equal sign. And for normal distribution, we say NORM DIST. And then the first number you need is this 4000, which is of interest. And then it will ask you for average or mean, which is 3192. Then it will ask for standard deviation, which is 1181. And then it will ask you whether this is a cumulative calculation. And please note that in this situation, we always do cumulative calculation. For normal distribution, we should always use true. It is a cumulative calculation. So by cumulative, I mean when demand in which we are interested is less than or equal to 4000, so that's a cumulative calculation. But if somebody is interested in calculating probability for demand equals 4000, so that will not be cumulative. So if you enter this, this will give you the answer. So X means the value of interest, in this case is 4000. And then automatically it says mean. So mean is 3192. And then it says standard deviation 1181. And whether it is cumulative, so we select true. So this gives us a value of 0.753, which means the chance that demand will be less than or equal to 4000 is about 75.3%. Another one you can do is, let's say we want to find out what is the probability that demand is between 2000 and 4000. So anywhere between 2000 and 4000. So if you make a picture of this, it will look like this. So average is 3192 and sigma is 1181. So 2000 is somewhere here, 4000 is somewhere here, and we are interested in this area. So what we do is we first find out area to the left of 4000 and then subtract area to the left of 2000. So that will give us the middle area. So this is same. So if you enter this in Excel, let's do that. So this gives us 0.597. So the chances are 59.7% that the demand will be between 2000 and 4000. Now suppose in the first problem somebody wants to know what is the probability that demand is greater than 4000. So we know that this probability is 0.753 and the total area under the curve is 1. So we can always figure out how much this is going to be. So this is going to be 1 minus 0.753. So because the total area is 1, we can always find out the other part if you know one part. So these type of problems we can say are the first type of problems in normal distribution. Now let's look at second type of normal distribution problem. In the first type of problem, we are given the demand values and we are calculating probabilities. In the second type of problem, we are given the probabilities and we try to find the demand or the quantity. So one example is, let's say we want to figure out something like this. So D is less than some number question mark we don't know such that the probability is 0.75. We can put this in a pictorial form. So it will look like this. So we have this demand D, average is 3192, sigma is 1181. So what value of demand will give us an area 75% to the left of it? So note that at this value, which is the average, area to the left of average is 50% or 0.5, or area to the right is 50% or 0.5. So 75% means that point should be to the right of the average, maybe somewhere here, so that this whole area is 0.75. So the question is what this value is. So this is in a way inverse calculation. So given the probability, we want to find this point on d-axis. So because this is an inverse calculation, we use this Excel function NORM and then INV for inverse. The first number it needs is the probability, which is 0.75, and then the average and standard deviation. So if we enter this in Excel, we get the answer. So we get 3988.6. So this is the second type of problem we deal with when we are using normal distribution. So let's do one more example. So let's say we want to find a situation such that the area to the left of a demand value is only 40%. So using the same situation where we have a demand distribution which is normal with average 3192, sigma 1181. Now area to the left is 40%, so that point should be to the left of average, because to the right of average we'll get total area to be more than 50%. But because this is only 40%, so this point is going to be on the left. So this area is given as zero point 0.4. Now the question is, how much is this value? So we do NORM and INV 0.4. 2892.8. So this is how we do the inverse calculation in normal distribution, and given the probability values, find the demand value. Coming back to the problem we looked at earlier. So we got a critical ratio of zero point 0.8. So this means if you have a demand model like this, where average is 3192 and sigma is 1181, this is the second type of problem you can see. We are given the probability. So 80% means the point will be to the right of average, and this area is given to be 80%. We need to find out this value here. That will become our optimal quantity based on critical ratio calculation. So if you insert these values in Excel, you get 4186.